The most momentous second in history, the first.
In that first moment of creation, in the first second, space and time, matter and energy, everything was set into motion.
Space and time burst into existence, giving birth to the universe.
More things happened in that first second than will probably happen in the entire future history of the universe, no matter how long it lives.
This violent first second will define everything, including you.
So that very first second, understanding that is the key to understanding the universe itself.
Look up at the night sky, at our universe. An awesome spectacle, stunning, exhilarating, humbling. And look at all the world around us, bursting with life, with natural wonders, with those we love. All of this, everything we see, comes from one miraculous moment, the Big Bang.
The Big Bang was more than just a creation of matter. It was a creation of the universe, which means a creation of space and time.
Creating time, space, and everything is a pretty neat trick. Obviously it happened, but so far physics hasn't figured out how.
We don't know why it banged. We don't know what banged. We don't know how it's banging.
All we know for sure is that all of existence suddenly bursts into being. This is the beginning of the first second, when time itself is set to zero.
It's the moment when everything we see, all 100 billion galaxies, each of which contains 100 billion stars, all of that material was compressed in a region which was infinitely small.
In its first second, the universe evolves more radically than in the 13.8 billion years that follow.
The first second of the universe was the most important second the universe ever had. And it went through more stages in that first second than it has in all the time since.
So much happens so quickly that scientists need a whole new concept of time.
For human beings, 1 second can seem like a very short time. But for the universe, an incredible amount can happen.
We measure our lives in hours, minutes, and seconds. But they're useless at the time scale of creation because the Big Bang unfolds almost instantaneously.
We have taken our understanding of what the universe was like back from 1 second to a tenth of a second, a hundredth of a second, a thousandth of a second, a millionth of a second, a billionth of a second, all the way back to a time where the laws of physics, as we now know them, break down.
That far back, time must be measured in unimaginably tiny slivers, known as Planck time.
One way of understanding how much actually happened in the first second is to think in units of the Planck time. The Planck time being 10 to the minus 43 seconds. There's a billion Planck times in 1 second. There are only a billion seconds in the entire history of the universe. That's far fewer seconds in all of history since 1 second to today than there were from the Planck time to the first second.
By breaking time up into such tiny fragments, we can imagine the birth of the universe moment by moment. In the beginning, space and time are wrapped up in an infinitesimally small speck of pure energy. As the Planck time clock starts running, this knot of space and time somehow breaks free.
The Big Bang wasn't an explosion in space. It was an explosion of space.
As the hands of our cosmic clock approach the first Planck time, all of space expands. The universe emerges everywhere at once.
The wonderful thing is it happened right here at the end of your nose, and it happened 5 billion light years away. Every single point in space was involved in the Big Bang.
So it's not as if it's a ball that you can stand outside of. Everywhere you are is inside of the Big Bang.
In this very first instant of creation, some scientists believe that a single pure force, a superforce, rules everything in the universe.
We think that the original universe was a state of perfection, a single unified force that existed at the instant of the Big Bang.
As the first Planck times pass by, something causes the superforce to split, shattering this state of perfection.
As the universe cools, these different forces freeze out. That means they behave differently.
Think, for example, in terms of steam. If I have steam and I cool it, it turns to a liquid. If I cool it again, it turns to a solid. So in the same way as the universe began to cool, the different forces broke off from each other.
When the superforce splits, a new force emerges to drive and shape the cosmos. Gravity. It will mold matter into planets, stars, and galaxies.
If gravity were a little bit stronger, perhaps we would have had a Big Bang, which would stop, and then it would recollapse immediately into a big crunch. Life would be impossible. If gravity were a little weaker, then we would have a Big Bang that just keeps on going, and the universe would freeze to death.
But gravity breaks away from the superforce at exactly the right strength to create galaxies, stars, and life itself.
So our universe, in some sense, is fine-tuned. We're just right to have a universe that expands slowly, making it possible to create DNA and life as we know it.
Gravity may be the perfect strength in our universe, but it's not the only force that will govern the cosmos. By the 10 millionth tick of the Planck clock, another stupendous event will begin. The wildest growth spurt in cosmic history. Gravity has begun shaping the future of the cosmos. But as the universe expands and the temperature drops, another force arrives on the scene, the strong force.
Without the strong nuclear force, the nuclei of the atoms themselves would all disintegrate.
Three forces, gravity, the strong force, and the fractured superforce, rule the universe as it hurtles towards its next milestone. An event that sets out the blueprint for the galaxies that fill the cosmos today. We think this event happened because it explains a long-standing mystery. Everywhere we've looked in the universe, its billions of galaxies are spread evenly, the same number in every direction.
All of these parts of the universe must have at one point been in contact with each other. It's kind of like having two people who live on opposite sides of a country, getting up at the same time, eating the same breakfast, dressing the same way, even when they don't talk to each other. There must be something common in their past that links them.
This problem needed a solution. And in 1979, a young cosmologist named Alan Guth proposed one. He called it inflation.
It was very exciting. I suddenly realized that this might be the key to a very important secret of the universe. But at the same time, I was, of course, very nervous because it was all new and I was shaky about whether or not it was right.
Guth speculated that the infant universe went through a phenomenal growth spurt.
Cosmic inflation was a moment in the history, the very early history of the universe, when the expansion suddenly accelerated. It got huge for the briefest moments of time.